So when you start making a drawing, how do you know which views to draw and in what order to draw them? Well, to decide which views to draw, you need to figure out which views are going to define the part, that is, show the sizes and shapes for the person who will be using your drawing. Sometimes you don't need 3 views, sometimes you do. In this L-shaped bracket, if you look at this drawing on the right, that doesn't have enough views because it needs a view to show that slot in the leg of the L. If there were no slot there, maybe you could get away with 2 views, but for this part you would need all 3. There are many parts where you only need 2 views, like this bracket here. A side view wouldn't tell you anything. Round parts, many round parts are like that too, where you can show just 2 views. And there are some parts where you only need 1 view. For example, this section view of a washer over here on the left just needs 1 view. You can dimension the outside diameter and inside diameter in this section view, and you can dimension the thickness. That's all you need. Or over here on the right, this drawing of a printed circuit board panel. If you have a note calling out the thickness of the fiberglass right here, or you call out the material in your bill of material or your parts list, you only need 1 view. You want to use the minimum number of views necessary to define the part for a couple of reasons. One, drawing extra views takes more time for you, and your boss is going to be interested in efficiency, so how many drawings can we make in a day? And also, the machinist who's reading your drawing will spend extra time trying to figure out what this other side view is trying to tell them. And maybe it's not telling them anything and they've just spent extra time thinking that wasn't necessary. So we try and keep our views to a minimum. And we think about which views are going to give them the most information. In this particular L-shaped bracket, you could pick a left side or a right side. This drafter has picked the right side because they're able to show a visible line here instead of a hidden line, which causes more thinking trying to figure out what that is. The most common arrangement of views, of course, is the classic top, front, and side view. That's far from the only arrangement. It just turns out to be convenient a lot of the times. When you're trying to figure out which view will be the front view, it's up to you. You get to pick which side you want to be the front. So pick the view that you think is going to show the most information. In the case of this is probably a bearing pillow block. So for this pillow block, this happens to be a metric drawing, this drafter has decided that this thing with all the circles and radii and the flanges, that's going to give the most information about that pillow block. Then when you draw that front view, try to show it in its natural position. In other words, if this thing were just sitting by itself, let's say on a shelf in the parts room, what side would be down? Well, probably the parts person is going to set this long flat side down on the shelf. So that's the orientation you would draw in your drawing. They would not be setting it on the round thing, so we don't want to draw it that way. Then, when you draw the views, in a mechanical drawing, you never label the views. You do not write front view under here. No, no, no. We don't label those views because our machinist or our fabricator doesn't care which view you think is the front. What they care about is what shape is this thing and what sizes are all these features. Now, this is different from architectural drawings. In architectural drawings, we do label the views, but in the mechanical world, we never label the views. And you can use this glass box idea that we talked about earlier to help you figure out where do the side views go, where do the top and front views go, and so on and so forth. Practice visualizing this glass box arrangement. That's a key skill in drafting. And of course, it's essential that these views be aligned every time. Now, if you have two views and you want to draw a third view, like let's say you have the top and the front view here and you're trying to figure out how to draw the side view, there are a couple of techniques left over from old-time drafting. In the old days of board drafting, people used to use what's called a miter line. A line, they'd get a 45-degree triangle and actually draw a 45-degree line on their paper, and then run projection lines over from the top view, and where they intersected the miter line, run them down into the front view, into the side view. A variation on that is to draw with a compass, or now in CAD with circles, to draw radius lines. You can still do those methods in CAD, and some people like to do those methods in CAD. They work perfectly well. I'm a fan of this method, and I'll show you when we look at drawing your first drawing assignment in CAD. I'll show you how I would do that. I like to, in CAD, to make a copy of my top view, rotate it 90 degrees, run projection lines down into my side view, and then I delete my temporary view up there. This is the part that we are going to be drawing in our first assignment. So we're not going to dimension anything. We're just going to draw a top, a front, and a side view. That's all. We're getting comfortable with the glass box and the three views and all that sort of thing. There is a CAD model, that is a CAD drawing, that's drawn in 3D that might help you visualize this thing, and I'm going to show that to you in a minute in the next video. And you will be using your standard class title block for this drawing and for all subsequent drawings. So for this drawing, you'll get that mechanical drafting title block, and you'll save it to your computer. And now you want to change a little bit on your title block. Here is the description of the part. This thing is called a guide, so change that word. Here is the assignment number. This is assignment number 2. And change the name to your name, and change the date to the date that you drew this drawing.